Welcome, everyone. This is the first time we are doing this in a Zoom platform, so we are very happy. Now we have more interaction, I guess, and that will be really good. Have you all here. This webinar is offered by NIRx. So we are an fNIRS company, and we are always looking for innovation and more interesting things, solutions for your research. As you can see there, we have done already some tests in the park. We do some tests here at the office. We are always looking for what's best for your research. And we are very excited today, actually. So we have a launch of a new software for fNIRS analysis that's in collaboration with Brain Innovation. So Brain Innovation, it's a company that's been there for the fMRI analysis for a while. And for that introduction of the software of a new product, we also have here our Director of R&D, Dr. Alexander van Lumen. And we have also the Brain Innovation Senior Developer, Dr. Michel Lührs. And we hope you enjoy our webinar. Before we start, I have to say some of the considerations. So I'll be the moderator. I'll do some Q&A sessions in the end. We have also Amelia Young in the back helping us there. And we also have Dr. Milan Harry here, our Director of Customer Success, also helping us during the webinar. For now, you are all muted. Please, the questions are welcome at any time. We've already received some questions from you when you register, so that will also be answered in the end of the webinar. The webinar will be available in our website as it's there. And if you have any further questions, please let us know. Send us an email at consulting@nirx.net. Thank you very much for being here. And Alex, mic is yours.
Thanks, Made. So my pleasure to welcome everyone again on the behalf of the NIRx team. Yeah, I mean, I think we're hopefully all aware it is great. The field has been growing rapidly, and it is continuing to do so. And we're trying to support that as well as possible. One way of doing it is by trying to achieve wider adoption through software that is easier to use, that requires less training, and that can maintain or help you to generate output in the form of meaningful results in high-impact papers. So software plays a big role. And Satori now is a commercial software that has 4 main goals. I want to briefly go over before we start talking about what the software, how it looks like, what it actually does. So Satori aims to make the workflow of a researcher easier, but also maintain the powerful tools of any advanced analysis software. So the idea is that you can interact with and see your data at any time throughout the processing. You can easily visualize it. You can understand it better, how it is transformed, and also what decisions to take on the data. So that is one. Second, the goal here was and is that it is easy to learn and to communicate and collaborate with it. So you don't have to know how to program. It is self-documenting. Pipelines in the software can be shared across with your peers, but also with reviewers. For example, if there's a question, you can rerun the pipeline and know that everything else is identical, only the changes that you made. So this is point 2. Then overall, the architecture of software plays always an important role in terms of maintenance, but also data safety and privacy. So Brain Innovation will hear more about Brain Innovation, and the software, of course, in a bit, has gathered a lot of experience in this over the last years. So basically making use of that in Satori. And lastly, and this, of course, personally makes me very, very happy looking at innovation and our technology that we're trying to move forward. It will enable us also to offer full integration with new innovations from NIRx. For example, our NIRx Borealis, an MRI coupler for the NIRS-2. The Satori Brain Voyager is a software that has been established in as a commercial software in fMRI. And with Borealis, we will be able to measure the NIRS2 fNIRS based signals in the MRI, and now also there will be 2 software analysis suites that are very similar in the architecture, which means that fusing that data and analyzing it will ultimately be also easier. So there are some perks and advantages in well, creating let's say, a full ecosystem. This includes other innovations that we're working on, like wings in the future, including software packages that enable the analysis of NIRS data, integrating these new data that you can measure with NIRx devices. So this is 4 main reasons, but overall, why do we work with Brain Innovation? Brain Innovation has been a great partner over many years and has a lot of experience with exactly what we have been talking about right now. So Brain Innovation and its CEO, Professor Rainer Göbel and Dr. Lührs next to me, and the colleagues have built Brain Voyager as the leading commercial fMRI analysis software over the last years. And NIRx and Brain Innovation have been collaborating for more than 3 years now to build Satori, which is following basically the same architecture and translates 20 years of learning from the Brain Voyager path basically into how to build good workflows into an analysis software for fNIRS. So Michael will say a bit more about Brain Innovation later in the presentation. Let me briefly introduce you, Michael, to our visitors here. It is my great pleasure. So Michael studied computational visualistics in Magdeburg with a focus on medical informatics, and finished his PhD at Maastricht University and Brain Innovation in 2018. Yes. And his main interest was and is to develop new methods and technologies for real-time fMRI and real-time fNIRS, including neurofeedback. And after your PhD, you continued to broaden your expertise, specifically also in PCI applications for fNIRS, in addition to developing Turbo-Satori, which we have had in our portfolio for a while now, but also now at the development of Satori. So maybe can you briefly, we go back and forth for everyone here, and then Michael will start with the main presentation. Can you briefly motivate how Brain Innovation kind of ended up moving from fMRI to working with fNIRS data?
Thanks for the introduction, first of all, and thanks for having me here. Yeah, it was a long journey for Brain Innovation to starting with fMRI in around mid-90s, being one of the first software packages on commercial side. At that time, there was not that much software available in the fMRI field, so Rainer Göbel founded their Brain Innovation, and his main idea was to basically have a tool which he can use to analyze the data. And the tools that were available at that time didn't fulfill the requirements that he had. And that was basically the starting point of the company. And since then, the company evolved, and we were also looking at different tools also at NIRS. I think the first contact that we had with NIRx was in 2008 or 9 with the first device that we used in Maastricht. And since then, we started developing also software for fNIRS analysis, going into the same direction. And now the field is growing more and more, and we are doing more and more research in that field. And so for us, the same reasoning and the same ground truth is there, that we want to develop for our own research a nice software that we use to publish our data, but at the same time making this available to people, that it's easier, as you already said, easier to use, that it's easier to replicate the results, and also to share the knowledge across people.
Thank you. Yeah, so I think we're all really excited about this launch and also this collaboration. So today the topic will be Satori. So before we, let's not wait much longer learning about Satori. Just maybe briefly one important announcement or reminder to us all at NIRx. It's very clear, maybe not to all of our observers. This is a commercial software, but does that mean that we are not friends of open source anymore? No, it isn't. And Michael, you're going to talk a bit more about this, what that means, how Satori can be interfaced. Basically, it is just important to point out there are a lot of advantages with this commercial package in terms of being able to support it and train people. And at the same time, NIRx is supporting open source development heavily, and we're in touch with most open source developers out there, larger groups, and we will continue to do so. So there are advantages to both approaches, and these advantages, I guess you'll briefly mention also in terms of how Satori, where you can find Satori and Brain Innovation in that space. And so with that, yeah, I can maybe start the question, hand over to you. If there are open source toolboxes, why would you even use or need something like Satori? And how did you end up with the software that we're going to learn more about?
I think that's really a critical question. So first of all, the open source softwares are great. They are really nice tools for everyone to use. The major disadvantage that's there for companies is that we can't drive specific open source softwares in directions. So if we develop specific tools, we want to be basically in charge of these things. That doesn't mean that we want to that we are direct competitors. It basically means that we can enable tools and features quicker and make them available easier to people. At the same time, we want to interface as much as possible with the open source software so that people can decide at which point they want to go to the open source and to the closed source. And yeah, the third part is we don't try to make things closed source. As soon as much as possible, we try to make things open source. And this will also show up in the future when we will also talk about this later, but when we go to Python and to Python interfaces, we try to make our source code available, that people can replicate our results and their results with Python and basically can decide if they want to use the open source code or use the internal fast code that is in Satori. It's binary the same result, but they have the choice to go forward with one or the other option. But the usability is something that Satori will deliver, and that is something that we are also very, very proud of. To get started, let's jump in. I will start to share my presentation. Yes, I hope everybody can see it. Okay. Great. So I have a short outline of the presentation. First, I want to talk about who we are, just briefly explaining who Brain Innovation is, where we come from, then jump into Satori right away. And yeah, we had some questions about Turbo-Satori and Satori, so we'll shortly bridge the gap between the two applications that is easier to understand where do you use Turbo-Satori for, what do you use Satori for. And then at the end, an outlook what you can expect in the future, because the launch today is just a start for the next couple of years to come, because this software will develop and evolve over the next years for sure, and this is basically the starting point. So yeah, as you heard, Brain Innovation is the base company that develops Satori together with NIRx. Yeah, we are in Maastricht, the Netherlands, and it was founded in the mid-1990s by Professor Rainer Göbel. And then we started with fMRI, went on with Realtime fMRI, and of course the other tools like DTI, DGI, EG, TMS, and fNIRs. Some of you may know already the main software that we developed the last 20 years, which is Brain Voyager. It's a neuroimaging software package, which basically provides a lot of tools and features, and especially visualization in the field of fMRI. And one part of our software family is also educational software. So here you see two examples for free educational software, which is the Brain Voyager Brain Tutor, which you can just freely download, and the Brain Voyager Viewer. And this is there to help people understand brain structures, brain function, and can basically get an idea of these tools. So if you're interested, just check out the App Store or iOS Store, and you can try them. I think on the App Store, it costs a cup of coffee or something, I'm not sure, but on Android, it's for free for sure. Next to this, we also have some new navigation software for TMS, which includes full pipelines. So if you have MRI data available of individual participants, you are able to co-register and directly map the specific coil positions onto the participant's head and navigate to certain target points. This is also one feature. And next to that, we have our real-time software, Turbo Brain Voyager for fMRI analysis, which gives you access to real-time analysis tools in the field of fMRI, which is mainly used for BCI and neurofeedback. And you see a lot of these tools also in Turbo-Satori. Okay, if you want to have more information and more details about our products, just go to braininnovation.com. And every information about the upcoming tools you will find on the NIRx websites. And yeah, so without further ado, I want to jump into Satori. So let's start the software. I hope you can all see the screen. Okay, perfect. So Satori comes as a standalone software package for macOS and Windows. It's right away for Windows, but it will be available for macOS in the next couple of weeks. And I want to shortly just guide you through the interface so that you get an idea of what you basically see here. So in the top, you have your main menus to open a file, save a file, and switch between different views. There's a 2D view, 3D, and the respective channel views. So these can be either selected or eventuated. And next to that, you have some toolbars, and of course, in the right-hand side, you have a dialog with specific settings and preferences. Okay, to show you what the software can do, I will open a data set so that you get an idea how to work with the software. So I have the data here. Let's open this data set. As you can see, the software supports the following data formats, which is the fNIRS, the JNIRs, which is basically the fNIRS as a JSON format, or it's a binary format, then the .NIRs and the SRI. We will import header-based datasets, which were recorded with earlier NIRx packages and NIRx tools from NIRStar. If you have a problem with a specific dataset to open, just send us the dataset, anonymized, of course, and we will take care that it's possible to load the data within Satori. But this is true for all problems that you're facing. If there's a specific issue with a specific dataset, just share it with us. If you're not able to share, we are there to provide the support with, for example, a Zoom meeting or another remote desktop session. Okay, let's open the fNIRS file. So here you see the loading screen, which you will see all the time when the software is loading something. And this is the main interface of the software. You are able to zoom in and out as much as you want to specific parts of your layout. So you can really zoom in to a lot of detail if you want. And you see for each channel, basically the layout. If you want to get more information of specific channels, you can just hover above it, and then you see immediately the time course expanded. If you want to see the whole time course, you just click, and then you see the full time course in the top of the time series. In here, you have the ability to zoom in, for example. So look into specific parts, you can zoom out, or you can resize to the exact size that you want. If you want to look into more detail of this view, you can just open the event-related average, which opens here on the side. And here you basically see the event-related average with the standard deviation. So now it's a bit difficult, so you can just hide specific parts and see exactly the data that you're interested in. So if you don't want to see the standard deviation, but want to compare the time courses of two regions, you can just do this. But here, for example, it gives you a much cleaner view on the data. As soon as you select a different region, you see that the plot is directly updated so that you can just compare. If you want to switch between different chromophores, you can basically open just the toolbox, and there you see the options to select different chromophores. Here we, for example, can switch to deoxy, and then we basically see the time course for deoxy. As you can see, this is also shown in the event-related averages here on this map. So we can select multiple of these, which are then in relation to each other. You can also select, of course, 3, or we can have a look at one of them. If you open the software, if you open a data set, it basically starts with the raw wavelength data. We automatically transform the data now to concentration so that you can easily inspect your data at a glance. That doesn't mean that you cannot process it anymore, but it's just a convenience function that you immediately have access to the data in that space. But of course, you can also turn off this option and just look at the raw data so that if you open a data set, that it's just the raw data. Okay, looking a bit at the bottom of this dialog, we basically can see some information about the fNIRS format. So we can just open the fNIRS box here. And this gives you access to the fNIRS format. This is basically the whole structure of the fNIRS file, which you can't open with the text editor because it's a binary HDF5 file. But with this dialog here, you can access the data that you're interested in. So here, for example, you have full access to the data time series or to the time, and also, of course, to the specific measurement lists. So you can see really the settings of these data. In addition, you, of course, have all the information of the data set. So here, for example, the stimuli. The probe information is also very important, and I can shortly show you why this is. But next to this information, you can always mark specific parts and just Control-C or copy the data into whatever tool or format you want. So this data is not just visible, it's really accessible so that you can grab it. The same is true for the data time series. So as soon as you have done any processing, this data is updated so you can extract your processing directly and use it in any other tool that you want to compare, for example, specific pre-processing results. Okay. Next to the fNIRS format, we have the full data plot, and this full data plot is very important for data quality checks. So let's open this one. And as you can see, this full data plot basically gives you access to the full time series of all channels. So you can easily scroll through and check for specific artifacts or problems within your channels. If you, for example, have found a channel which you really think is not suitable, you can just mark the channel with Shift and click. And then I just mark a few more to show that. And then you can, for example, click Apply and Quit to mark them as hidden channels. If you want to mark specific epochs, you can just create a specific rectangle and mark epochs for later on cleaning routines. So for now, I just select 2 channels here and apply and quit. And then you can see that these channels are not available in the plot anymore. This is by clicking Apply Channel Mask, and then you can see that these channels are not there. You can still hover above them, but it makes it easy for you to understand if I select these channels from the full data plot, where is this located? And yeah, talking about location, we have the 2D view. Just open it here and close these views. The 2D view and the 3D and the general view of the time course are basically the same presentations, but here you also see the sources and detectors. If you hover above a specific channel, you can see the channel also marked here, and the other way around. So if I mark here a channel, or if I select a channel, I basically select them with either interface that I want to use. But this gives you a much easier interface to the data and to the software itself. Another way of looking at the data is the 3D view. And this view gives you all the information that you need to access the data and to see them in a glance. And I want to just make it a bit more clear. So I open a second data set. And this one is a finger tapping data set. And as you can see, the 3D view is now immediately updated into this specific setup. So if I want to switch between the 2 setups, I can just click on the different file that I've opened, and you can see immediately that the view is switched right away. The same is true for the time courses, of course. In addition, the 3D view has some important features. So if you go to Tools and 3D View Tools, you get an interface with specific options. So you see here that there is a face or the surface of the head mark. If you want to see this more clearly, you can click on surface, and then you can see it a bit more easily, right? If you want to translate or transform your setup, you have here in the top a translation option with which you can just move and define your setup. So if there is a mismatch in the co-registration of the layout and the head model, you're free to change this in the layout. And this includes a 12 theme matrix, so including scaling and shearing, so you can really align each point of the mesh of the reference labels to each design. The reference labels, by the way, are available here in the bottom, so you can select which of the system you want, and then you can easily accommodate to this label. Another tool that we will use later on is basically the selection of a specific region. So all the data that we see here is in MNI space. So if I want to, for example, check a location, I can just click there, and you can see here there's a little mark. What you also see is that there's a definition of this coordinate, which is the MNI coordinate, which you can then look up with an online tool, for example, but for sure also in a later version of Satori with a mapping to specific addresses like the AA atlas. But you can also change it around or turn it around and define a specific target MNI coordinate and basically place the optoid or this marker to this location. With this, you have basically the free possibility to know where you are in the data. Next to these options, you of course want to know if you are hitting the spot, so to say. So you can turn on the light. And this will then show you which areas you probably will reach. So if I, for example, put the cap a bit higher and turn on the light, you see that for the upper regions, there's no real excess. If I move it now, it's a bit slow because it's recalculating each step in time. So I just move it down. You can see easily the data here. But you can, of course, also change the color depending on what kind of visualization you want to use and how you want to interpret the data. Next to that, you can also change the size of the source detector labels or change the color of the probes. So how do you link specific areas from the 2D to 3D? And it's the same as in the other 2D view. You just hover above a specific area in the 2D view or in the 3D view, and you get the time course of this specific area. If you want to know how this time course looks like on the channel, for example, just click here and you see the time course of this channel. Okay, let's jump into some processing of the data. So we know that it's already processed in CC, so we don't have to do this at the moment. But what we also can see is that the data here has some long parts in the beginning and in the end, which we don't really need for our analysis. So how can we trim the data? For that, we basically just go to analysis and use our trim data tool. And in here, we can define multiple options depending on how you want to trim. So we can cut a specific begin, so just removing specific seconds in the beginning or at the end. But this is only if you know that your time course has a specific length, so then you can cut with these constants. If you have a protocol, you can easily cut before the first event, which we will do here. So 10 seconds before the first event, meaning that would be in this range here. And we also want to get rid of the last parts here. So we do cut after last event, and we want to have 10 seconds after the last event. And that's it. Then we click ensure that this is also applied to events, that the events are still on the correct time. Click apply. And that's it. And as you can see, as soon as you clicked apply, it basically adapted the whole settings for all time courses and for the whole visualization. If you have to trim in different ways, you can of course continue or combine different options here. Okay, great. Now, when we looked at the protocol, we saw here that they were listed as 2 and 3. which could be a useful name if you know what 2 and 3 means. But in our case, we would like to change this. So we go to protocol, and we see here now the respective protocol. So you can just hover above a specific epoch, and there you see the condition and the start and end time, which gives you some more information about it. But you can also just check at the values here to see when the start and end time of specific parts is. Now to change a condition, just click on the condition that you want to change, that name. And I know that this one was left-hand movement, I hope. And then for the second one, we change it to right-hand. Okay. So you can see it immediately changed the labels in here. But to apply this to the data set, we just have to press this button. And then you can see left, right is now part of our settings. And that's basically all we need to do for this part, that we know what kind of data we are looking at. Okay, how do we pre-process our data? There we can go to analysis and open the fNIRS data pre-processing dialog. And in here we find the general options for pre-processing that coming with version 1, but this is of course only the start. Now the basic information here are available, meaning we have short channels, so we can use short channel correction, but we could also integrate motion correction, for example, using the CBSI method. But let's stick to the short channel here. Since we don't, or we can check once more, let me shortly close this one. So we see here that we have a few short channels, but we don't have for each of the sources, sources a short channel. This you can also see here. In this view, you see little connections here. So D18, D17. So this is not enough to clean our data for each individual, because we don't have so the closest SR wouldn't work in that case. But we can, for example, use the PCA and extract from the first, let's say 3 components, the information only of the short channels. And then we use a GLM-based regression and can clean with that our data. Next to that, we use our temporal filtering. In this case, we can basically just do a low pass and a high pass filter. And in addition, we also use Z normalization to just normalize the data in a specific range. Okay, if you're happy with this, you don't need to change. You can just click on go and use the standard settings. If you're fine, you just click go. And that's it. Basically then have the full data pre-processed, and you can look at them now in this format. As you can see, we removed the fast frequencies, so the heartbeat, for example, and now it's also much easier to look at the eventuated averages. So let's look at the left hand. See a strong increase here, and let's look at the right hand. You see a bit lower, but here you can now really easily differentiate the 2 options. Let's look on the left hemisphere. There we see different, or exactly the opposite. We see a stronger or similar activity for the right hand and a bit less for the left hand. If you want to know where you are, you can basically just scroll here around. Okay, let's use some statistics to not go only to the visual part, but also to add some ground truth to the findings. So as we can see, we have a protocol in the back. So we know which events were going on at which point in time. So this we can use right away in our analysis. So we just go to analysis, click on general linear model. And in here we see right away the 2 conditions that we now renamed. So it's left and right hand. And let's see if we can find areas where the left hand was stronger than the right hand. And to do that, we basically just define our contrast by saying we want a positive or a higher activity for left compared to right. Then we basically just need to click on go. And now the software is calculating for each of the, for each contrast, in this case only one, the results. What you can see now is exactly this result for this contrast. And we can nicely see that on the right hemisphere, we have a stronger activity for the left hand as compared to the left hemisphere. So to check what we're looking at, it's basically oxyhemoglobin. So our statistics now based on oxy. We can also include deoxy. So you can see that deoxy basically is now the second choice, or the second column here. And you can see that it's nicely matched for oxy and deoxy, but even we get a stronger, in this case, contrast, so T statistics for this specific option. But here it's a bit difficult to see where we are. So let's check back to oxy and go to the 3D view. So as you just saw, I accidentally clicked on the first data set. So this automatically loads the data set without the specific statistics. So this is really individual for each data set that you have opened. And now you can see here quite easily that for left and right, we have specific activity. And we can also see nicely where this basically is forming. And there you can see that these two channels are forming here over this area. And yeah, if you would look up this coordinate, you probably would find M1 or motor cortex in this area, which probably matches what was tried to achieve in this context. Then also on the other hemisphere, you see the same or similar pattern. You have to keep in mind that this is one example brain. So it's not an individual brain. So the regions can or will, of course, differ from participants, but you can load data sets, of course, from Brain Voyager, so individual data sets from participants into the software if you want to. But here it's basically the first part. Okay, so let's jump back to our presentation. What we've now looked at is basically the software opening data set and clicking through. And this was, I think, quite straightforward to interact, but of course, it's a bit a pity if you have to do this for each individual subject. So what you know from a lot of publications, you have this data analysis workflow, and you have different steps that you do after each other, and then you come basically at the end to specific analysis, single subject or group analysis. So how is this achieved in Satori? So to check how this is achieved, we basically jump directly back into the software. Let's see if we can just open another one. And we open now the workflow manager. So the workflow manager is basically the answer to this question. How do we generate pipelines that we can use on different computers and replicate for our analysis? And first of all, it's a pretty straightforward way of using this pipeline generator or workflow manager. You just drag and drop the item that you want to use into the field, and it creates this general item, or you just right-click and select an item from the list. Since we will have more and more items in the future, so more and more tools, it will be a bit messy to look up the specific features. So you can already here just type in what you're searching for. So for example, now we need raw and just type raw. So I find this one and I just click on it and basically have the option here. Now, opening a data set is straightforward. You just add the data set. So I just go to the data set that we just used. So it's the same one. And then you can basically see the data set that is loaded here. Then to basically apply a specific method, I just have to connect the two options. So just click on this option and connect it to the other one. And that's it. So this is basically my first workflow. But of course, I want to do a few more things. So from the raw to optical density, I can go directly to concentration. Then, for example, just apply some filtering. So I just connect them. Here I can define specific settings as in the dialog that you saw before. These settings are, of course, interchangeable and will add over time. And yeah, let's add the data storage at the end. So with this pipeline, I just store it in a different folder. So just store it here. Basically can say, okay, for all data sets that I've loaded here, so in this case, only one, for example, I want to store this data set with a specific suffix in a specific folder. And that's the main idea of this whole process. Now, if you want to run this data, you just click on Run. And then the Flow Manager will guide you through the individual steps. So it will tell you which steps it's currently working on, and it will tell you how much of the work is already done. And as soon as as the data is performed, it basically is finished. You can save this workflow. So we just example, just save it here, and you can of course also load it from a different source. Most importantly, this workflow is just a text file. So you can also edit or look at this data in depth and see what it basically contains or consists. So if there is a problem with any of the data, you can always send us the flow, and then we can have a look at the specific data sets. Okay, so I don't have the time to go through all the steps, and we will have more webinars on the software in the near future, but also in the next upcoming years, will be always webinars about features that we are working on. But in general, this is the main list of Satori in the V1 state. And it will mainly include the standard filters or the standard sets that you have seen. If there's anything that is particular interest for you, don't hesitate to reach out to NIRx, and we will consider or check what are the ability or possibilities to add this specific feature in the future. Now, some of you have asked about the real-time software, so I shortly want to give an idea of what this combines. So Turbo-Satori is the real-time software, and real-time means it really grabs the data as soon as it's recorded and tries to analyze and pre-process. And to show you how this looks like, it's basically that you connect your NIRScout or NIRSport 2 directly to the Turbo-Satori application. And this you can then, for example, use for BCI neurofeedback applications or for quality control. So you can just let it run next to your experiment, because then you get the T statistics, the output, and can really verify that the participant is doing what he's supposed to do in the session. And from here, if you're doing the Turbo-Satori analysis, the idea is that we seamlessly integrate the results from Turbo-Satori into Satori. And this should include all the settings that are either way in the fNIRS format, but as well as statistics, raw data, preprocessed data, and protocols and additional parameters, so that you can easily see if your real-time processing also gave you the results that the offline processing would achieve. So that is also in the same way of the transparency that we want to achieve. Okay, so what's next? That's, I think, the best question at the end. We have some future plans. That is, of course, that we seamlessly want to integrate new features, especially the ones that are of interest to the community. And this is a continuous development. So today is the start of this, and we will develop the software in the next years further, so that we basically have at some point an established user community, so that not only we will support you, but also the communities there. And this is also what we will achieve with a base of learning material and online courses that will be then available all the time, but in general, that we keep our material up to date. And this brings us to the topic of support, because this is one of the advantages of this application. If you have a problem with the application, if you're not sure if your data is in a certain quality, if you're doing things right, just contact support and we'll try to help you. And this is really important. Don't hesitate, reach out to us so that we can really help you. If there's a problem that you can't open a file, that there is a bug in the software, because that's always possible, reach out to us and then we try to help you as soon as possible. Future features that will be integrated are Python, meaning general Python interfaces to Satori that you can call and add features from Python into Satori and the other way around. Then we will have bits integration as soon as we reach a standard level of the bits format for fNIRS. And one thing that is on the list is the Satori educational version. What is this? In general, it's the full Satori, but it's limited to specific data sets. And the idea is to give students and people that want to learn how to analyze NIRS data a basis, a software that you can just freely use, but analyze specific data sets, so to say. So if you are interested and want to give a course and you have your own data, you can always reach out to us that we can integrate your data into the Satori educational version later on, so that you can use this data in courses or for specific teaching purposes. And this is already available for Brain Voyager. So if you want to try out some fMRI analysis and want to learn how to do that, just go to our website and download the Brain Voyager educational version. It's a full Brain Voyager, but limited to specific data sets. But there you can already get a grasp also of the Python integration and the Python notebooks, which will come in the future. Okay, with this, I'm done with my part, but I would like to hand over to Madi. I think you have some more questions available.
Yes. Let me turn on the video again for our room so you can also see us. Yeah, now you can see us. Good. First of all, thank you very much. Michelle, was really nice. I mean, I've been working with you a lot on this launch as well, so it's really good to see that we have reached the point for the version 1 and we have put all of good things in there. And I hope everyone that's there also enjoyed. Please feel free to make any questions. So we have some questions already that we're going to start with. The first one actually, it's about should I buy the Satori, how the licensing works, all of this and that. For that, we have a very special guest to answer these questions. So we have invited our general manager, Dr. Patrick Britz, to talk to you a little bit more about how this will the Satori licensing work and why this is very, to make your research easier. So Patrick, feel free.
Madi, thanks so much. Very happy to answer that question. Was it really asked, shall I buy Satori? Because then it would be very simple. The answer is yes. But let me answer about licensing models. So we learned from it. It's the first commercial software that NIRx is responsible for. And we go with the model also used and proposed by Brain Innovation, which they have for Brain Voyager, which works as follows. So you get the software and you get 2 upgrades, the next 2 upgrades, which come out in about yearly. So we will have a fast one, which doesn't count because we're still improving quite a bit. But then you will get that next year's and the year after. So up to about 3 years where it is fully supported. We only support the latest version of the software, but you can keep the license as long as you want. It's just not supported. And we recommend that you obviously stay with the current version, and we will make it in a fashion that it is attractive to always be with the current version, not just for the support. There will be 2 types of licenses. The one is device locked. So by device, we mean here a laptop. So you can have it on a laptop and you can take it off that laptop and put it on another laptop. So you have a device-based license where then one person, whoever is in front of that laptop or computer, can work with this license. And there's another one where you have network licenses where you have it on a computer and it can be used within a network. It takes a little bit more work to set it up, but again, a concept that we know already it works. And then if you have, let's say you have 2 licenses, then at the time, 2 people can work with it, but as soon as one person logs out, another person can log in to the license. Other than that, it works the same way as the standalone license, that you get 2 upgrades free, and we support you with, so as long as you have a current version of that. I hope that answers the question. Thank you.
Thank you very much, Patrick. Yeah, if you have any other questions about licensing or about, of course, the pricing and everything, please feel free to send us an email or consulting@nirx.net. You can also talk with your local distributor. You already know we have excellent partners throughout the world, so feel free to talk with them about that as well. So going more into the specific questions, Michelle, you talked a bit about the difference between Turbo-Satori and Satori. That was one of the questions here as well. But also, is it, so if I do my neurofeedback, my BCI, can I also get this data in use in the Satori, the analysis part and the statistical part, that's possible?
So the basic answer is yes. The only problem is that usually you have your own neurofeedback pipeline. So you have your own way of presenting the feedback to participants. We have, of course, a standard set, but usually you have your own way. And there you basically just have to export the feedback in a way that it's able to be readable in Satori. But since we have clear type text for the protocols, which includes also parametric weights, which, for example, you could use for this neurofeedback part, it would be very straightforward to integrate the 2. But as I said, if there is something that doesn't work, really just contact the support, and then we can try to figure out a working solution.
Perfect. One other question that we have, I think 2 or 3 people asked that, it's also about the short channel analysis, and is that integrated? How can I do this in Satori?
Yeah, so the short channel pre-processing, as you saw, is one part of the pipeline. The other one is that you can add the short channels as regressors into your GLM. And then you can also decide if you add 1, multiple, or specific ones. That with the specific ones is a plan. It will be released probably this year. But right now you can add multiple regressors together and then basically see the contribution of the specific regressor in your GLM.
Another question we got here was about montages. So we saw that when you open the SNIRF data, you can already kind of see the montage there, but is it possible to change? Is it possible to digitize? How is that planned also into the Satori software? So
for the design of the layout, we recommend to use the NIRx tools that are already available. But you can change the design within Satori in the 2D view, and we will later on also provide a change in the 3D view. Right now, it automatically loads the data from the SNIRF file if it's present. But if it's not present, you can load another probe info, for example, probe info file with the settings, which is then exported, for example, from the NIRx setup. So you can also just make a screenshot of the specific 3D view, or you can also create a specific statistical map, which you have created in Homer, for example, and then load this into Satori. So there's really a mix and match between the applications.
Perfect. That leads us to the next question, actually, which is, integration with the Satori and this other open sources toolbox. You mentioned Homer, but we also have the NIRS toolbox that we currently support as well. And how do you see this? And
so we try to export all the data at each point in time. So when you looked at the workflow manager, after each step in the processing pipeline, we export a SNIRF file. So you can go into the temporary folder and really grab each individual file. But of course, you can also create a workflow which stores at each point a separate SNIRF file. And this is all available to all the other open source software, so they can just read in our data sets. Another part, as soon as the Python integration is available, there, as I said already, we will make specific features and tools that we use, the modified Lambert law or GLM operations in Python available, so that people can see what is going on and get basically binary the same results with Python as compared to Satori. You have to keep in mind with the open source world, there are always these differences. So Satori is a closed source application, but it will make available that you can use open source like Python source code in your application. Homer is an open source tool, but it uses, for example, MATLAB as a closed source tool in the background. So there, we're basically going for the same model. We're a closed source application allowing you to read and load and apply open source code so that it's possible for you to really share your code with other researchers and having the flexibility and user-friendliness of Satori at the same time.
Yeah, that sounds really nice. I mean, that really contributes also to the open research that we share more and really understand what's you're doing to your data, which that's very important. Okay, let's go to the next. And here we have also a couple of questions about group analysis and multi-run analysis as well. How is this planned, or is it already integrated in the Satori software?
Yeah, so basic tools for group analysis are integrated, but there will be the full set that we see in Brain Voyager will be in Satori as well over time. But right now, it's the similar dialogue that you have seen in the single study. It's also the same one in the multi-study. So you have your different contrasts, you have different statistical models, but we also need tools like dummy coding and ANOVAs and ANCOVAs, but these are all planned in the pipeline already, so they will come. So as soon as you have specific needs, again, contact us so that we can streamline specific features earlier or later if you need them.
Interesting. Also, and then more or less on the same topic, so can we export, for example, t-values and p-values that we saw already in the software for second level analysis, or just export if I want to do in a different software, for example, my analysis part, my statistical part.
Yeah. So the general statistics are exported as text files and as Excel files. So you can get your t, betas, p values for each channel, for each chromophore. This is automatically exported when you run the GLM. But then in addition to that, there is, of course, access via the Python interface at a later stage. And if so any statistical output that we generate needs to be exported. That's our main premise. So if there's anything that that you would need as a feature, yeah, please let us know as well.
And that also brings to another question. So you were talking about pipeline that we can export, and how can I, if I use the Satori and I want to write my paper, how can I export all of this analysis pipeline to mainly to really write my paper according to the analysis I did, so everything is very transparent. Yeah.
So the analysis pipeline, as you saw, is basically a prepared image that you can basically use as a guideline to write up your paper, because you have step-by-step connected features that you can just we first perform this step with this pipeline. One idea that we had is to automatically write that part as a text. So let's see how far we get with that. But that's exactly our goal. So we want to streamline the pipeline that it's possible to replicate. So you don't have to write it in your words. We want to write it in standard words that people can really get the same results with their tools and with their pipelines. So that's the long-term goal. And we start with this pipeline that you basically save, and then you have really these parameters available. And also with it's saved in this format, there's the version and so on. Next to that, there will be PDF outputs that just list what you have done.
Okay.
But of course, to integrate this into a paper, you have to just go through and write it now, but we hope to be able to provide something in the next years that writes this part for you.
That would be definitely amazing. Just click a button, my part, it's written. But that's already really good that you can really see and start writing everything that you did in your data very clearly. There's another question about information on the possibilities for event-related fNIRS analysis as well. How do you see that for the story?
Yeah, so right now we focus on the event-related averages that you have seen, but there should be more options that we will also grab from Brain Voyager, which include basically deconvolution analysis, and specific event-related analysis. They are not integrated right now, only as specific protocols and statistics that you can define in the range, but it's definitely planned and on the list. So yeah, one of the definite features that will come sooner than later.
That's also another question that we've been asked sometimes, like, has a Satori been reported already in any peer-reviewed publication or currently being used in a study? I think that you can.
Yeah, so the basis of Satori, which was mainly also with Dr. Bettina Sorger years ago, are fundamental features and tools which are also available in Brain Voyages. So the features and the methods are there and used, and you can check the literature on these parts. As soon as the software grows over time, we use it ourselves. So we will publish with the application, but also we expect that other people will publish. And we also hope for comparison publications of open source like Homer or NME tools, where you basically see the differences and the different implementation of these tools. But in general, it's with every software. If you publish a software today, there is an update tomorrow. This is not yet published. So you have to be sure that you know what you're doing with the software. And there, the publication is important. That is basically the basis is there, but then you have to know what you're doing and what you're looking at. And that's why we focus always on the data in Satori, that you can really see the time course, you can see the model fit, and you can see what your statistics is based on. And that you not just look into T or P values and you don't really know what does it represent. And that's our basic idea. And that should also really represent that you know what you have done to your data, so that you can report in your article what you have done, and of course always mention the version of Satori.
Yeah, that's very interesting. It takes out of this kind of, when you think about a software that's a black box or something that I put something there and something comes out and I don't know really what it is. So with this, you can really see at all times your data. So that's pretty interesting.
But if you have a question from a reviewer that wants to know how this method works, reach out to us, that we can clearly explain it, because this is not a closed box. So to say that we don't want to share this information, we want to have really open science and research available. So if you need this information, just reach out to us so that we can prepare this.
That's interesting. You talked about Dr. Bettina Sorger, and actually she is here in the audience. I don't know, she asked a question. Bettina, I'm not really sure. Do you want to ask your question actually live? You can.
I can, yeah. First, thanks a lot for organizing.
Here.
Do you hear me? Yeah?
Yes.
Yeah. Okay. First of all, thanks for this great webinar. Michael, also thanks a lot for this presentation. My question was just for curiosity. Is it already possible to get 3D group representations of fNIRS data? Because this would be very exciting for us to have this.
Yeah, no, so that's really exciting. It's not yet available, but it's definitely very exciting to look at it. But that's one of the things which is really great, that we know we are working together quite a regular basis. So that's exactly what we want to have. This is a basis from which we basically start the next years to develop exactly these features. And yeah, so I'm really looking forward to integrate also some of these features.
And I saw already that you defined the trials in this paradigm in a single trial session. So I assume that a multivariate analysis for single trial decoding would be also a feature that comes up soon or is already included.
Yeah, exactly. Yeah.
Okay. Great.
Thank you very much. Another question that we have, main on the 3D. So I think you kind of answered a little bit, but if it would be possible to import digitized coordinates from a 3D party, for example, into the Satori software. If I digitize my positions, can I use this in my analysis later on?
So this is not yet possible. We try to integrate, so we're working on this with the group, but the main problem with this is that there are many different devices, many different formats of the source positioning, and also some errors in the positioning of these target points. So in case there is really some specific question that you want to answer, and if you can share data with us that we can take a look and see if we can integrate it, that would be amazing, because that's of course would be nice. But we also plan to integrate a co-registration procedure that you can automatically co-register your recordings that you just mentioned onto the MNI head, so to say. But that is more or less on a long-term goal. But it would be great to know which tool you currently use to digitize your CAP.
We have another question from the audience here. Najibur Hamman, and I hope I pronounced the name right. Please, if you would like to make the question yourself, feel free to unmute. Otherwise, I'm also happy to ask.
Thank you for your nice presentation. I have a question that is it possible to measure the functional connectivity through this?
So we have a basis set of a correlation matrix, which just correlates each channel with each other. The main problem is the physiology, which kind of let us step back from too many connectivity measures, since we don't know how much of the physiological information is still in the signal. We want to integrate more of the connectivity as soon as we integrate more of the wings physio recording. And that is our main goal. So we want to first integrate a cleaning of the NIRs signal, so removing the physiological signals, and then we go more to the connectivity, because that is one of the biggest problems. If there is still residual physiological noise in the channels, that will reflect in all connectivity measures that you're using. So it is planned, it basically is there already, but the main features will come as soon as we integrate the wings systems.
Yeah.
Nice, thank you.
Thank you very much for the question. Anyone else has more questions? Okay. I think we already went through all the questions that you asked before the webinar. So thank you a lot for everyone that contributed to the questions before as well. And it was a pleasure to have you all here. Please contact us if you have any questions. The email consulting@nirx.net, you already know. Is it possible to have some demos from us as well, so we can show you the software again, we can show you, we can provide a data set as well. So feel free to just reach out to us, and we will be working in close collaboration with Brain Innovation to get more features into the Satori as well. And like Michelle said, this is just the start, and we will be developing this software throughout the years as well. Thank you very much.
Thank you.
Bye.
Bye, everyone.